Okay, we've been tasked with this question. We've got two schools that are going to be located at points P and Q on a town map. And I really don't like reading an entire question out. I like reading it in pieces. So that's actually where I'm going to stop reading and start sort of actioning and start figuring stuff out for myself. So my first town is at point P here, and you'll have to excuse my cursor. It's not a nice big pen. It's this little floating circle that you'll see, and hopefully it is visible enough for you. And we've got this other one at Q, and I'm going to go right ahead and I'm going to graph those because I'm a visual learner. You don't have to graph these, but I really like to see what's going on and where things are. So there's my first town. That's town P, and then I've got this other town Q at 7, -2 over here. We'll call that town Q. Okay, so there's town P and town Q. Let's keep reading. The school board is planning a new sports complex to be used by both schools. That's wonderful information, but doesn't give me anything for this question. Not necessarily, not yet. The board wants to find a location equidistant. Equidistant. It's bolded, it's italicized, it's an important word. Equidistant means same distance. And so we are looking for a location of this new sports complex, a location, and I've got a coordinate plane, so location kind of makes sense, from the two schools. So something that is the same distance from those two schools. Use an equation to represent the possible locations. Oh my, okay. So there's lots to decipher here. How do I figure that out? Let's see, is this point over here the same distance from the two schools? No, it doesn't look like it. Is this point over here the same distance from the two schools? No, it doesn't look like it. Am I going to have to use the distance location and try to figure that out? Actually, no, there's another way to do it. So if we were to connect these two towns, say like this with a line, we wanted to find what is equidistant between these two towns just to begin with. Just one spot, just one location that is equidistant between these two towns. Can you think of a way that we would do that? And I encourage you to pause the video and try it out. So we should know how to get the midpoint. So let's take the midpoint of PQ, which is literally equidistant between the two. We're going to average our x's, average our y's. So -1 plus 7 divided by 2, and 4 plus -2 divided by 2. And so I get the midpoint of 6 over 2, 3, and 2 over 2, 1. So 3, 1. So let's just mark 3, 1 right here as my midpoint. And that is equidistant between the two towns. Now they said to use an equation to represent the possible locations. So I found one location, and this isn't an equation. How do I find another location that is equidistant between the two towns? Well, if we think about perpendicular, and we think about this idea of being perfectly 90-degree angle like this. If I had 90-degree angle, assuming that's perfect 90-degree, so here's my 90-degree sign, all of the points along this perpendicular line are going to be the same distance from P and from Q. When we think about an isosceles triangle, where the yellow line here is the base of it, and each of these green lines is just one of the arms or legs or other sides of the isosceles triangle. So if we can somehow get all of the points that are possible, and you might be thinking, well, that's impossible, it's infinite, right? There's an infinite number of points along this green line. Well, that's why they want an equation. They want the equation in y equals mx plus b format of that perpendicular line. You may have seen some of my other videos, or at least one, where I talk about a perpendicular bisector. A bisector means to cut something immediately in half, and a perpendicular is exactly that, a perpendicular line. So this is both a bisector and it is perpendicular. So we're going to find the equation of this perpendicular bisector. So I'll start by figuring out, what do I need to know for that y equals mx plus b? I need the slope for sure, and that's pretty much where we always start. But I can't just immediately get the slope of this green line. I didn't draw it correctly necessarily, but I can get the slope of the yellow line. So let's do that. Let's get the slope of PQ, and this is a lowercase m, not to be confused with the uppercase m. Let's get that slope by taking the deltas of our y values, so 4 take away -2, 4 take away -2, or 4 plus 2, and my x values. -1 take away 7. So we get 6 in the numerator, and we get -8 in the denominator. So our slope seems to be 3 over -4 after we simplify the fraction. Well, what does that mean for my green line? It means that the slope of my green line, otherwise known as the perpendicular slope, is the negative reciprocal of that, 4 over 3. So I can begin my equation 4 over 3x plus b. So the only thing left to get the equation of the perpendicular bisector that is the equidistant locations for this sports complex is the b value. And it looks like it's giving me somewhere around -3 or between -2 and -3, but I didn't draw it correctly necessarily. What can I place into my y value and my x value so that I can solve for the b value? I can only put the point that is on the green line that I know for sure, and that's the midpoint that I calculated over here, 3, 1. So let's do that. Put my 1 in for my y, put my 3 in for my x, and start solving. Now thankfully the 3's cancel, so that's nice. And I just have to subtract 4 on both sides. So I'll get -3 equals b. Now that means that the equation that represents all of the possible locations of this sporting complex that is going to be equidistant from P and Q is the equation 4/3 x minus 3. And like I said, the y-intercept looked like it was going to be around 3, and I was pretty close on my drawing. All right, so that is the equation that represents all the possible locations for points that are equidistant between two other values, otherwise known as a perpendicular bisector. I hope that made sense. Leave a comment if you want to, subscribe if you want to, and keep practicing math.